Hey students, in this lecture we're going to be learning about integration by parts. Integration by parts is something that needs to be done for some integrals. So some integrals are basically impossible to do any other way besides using a computer or a computer algebra system. But we're going to be focusing on doing the math by hand. So integration by parts is an advanced integration technique that's extremely useful. It can be a bit time consuming depending on the problem, but it allows us to do some integrals that would otherwise be impossible. Okay, so let's see an example of this, and I'll give you a formula for integration by parts as we look at the example. Okay, so example, evaluate. Okay, and for our first example, example number 1, we're going to be doing the indefinite integral of x times sine of parentheses 1/3 x n parentheses dx. Okay, so the integral of x sine of parentheses 1/3 x dx. Okay, so you could try to do this by u substitution, but you're going to find that it doesn't work. So for example, if you let u equal the inside of this composite function, sine of 1/3 x, so the inside of it would be letting u equal 1/3 x, but the problem with that is then du dx is going to equal 1/3, and there's not going to be an x to cancel out with this one right here. So if you try to do u substitution, it does not work. And you're welcome to try it on your own, but you could just take my word for it. U substitution does not work here. Okay, so u substitution does not work here. Doesn't work. Okay? But what does work on this problem, and a lot of hard integrals like this, is integration by parts. Now to do integration by parts, it's a little bit of an art. So you have to choose, first of all, a u and then a dv. And the formula we're going to be using, I'll write up here, is going to be the integral of u dv. Okay, the integral of u dv actually equals uv minus the integral of v du. Sorry about the baby in the background. That's my son. My fiance is taking care of him, but sometimes he throws a fit. That's all that you're hearing in the background. But he's being taken care of. Okay, so integral of u dv equals uv minus the integral of v du. So the thing here is, this is a formula that's always true. It's even true for definite integrals, but this one's an indefinite integral because we don't have any numbers to plug in. But this formula also works for definite integrals. And basically what this formula allows you to do is if you can write your integral in the form integral of u dv, then you can rewrite it as the right side. So you can rewrite it as u times v minus the integral of v du. So, like I said, it's a bit of an art. And because, what do I mean by it's an art? Well, you have to choose your u and your dv on the left side so that when you do the right side, it makes it easier to do this integral here. Okay? And this one's actually an easy one. But generally you want to choose u to be something that's easy to take the derivative of, and even more importantly, you want dv to be something easy to take the integral of. Because you'll notice here, we only have u and dv, so to get du, we're going to have to take the derivative of u, and then to get v, we're going to have to take the integral of dv. Okay, so the trick is when you're choosing your u and your dv, generally you want dv to be something that you can actually take the integral of, and you want u to be something that when you take the derivative, it simplifies the integral over here. So like with this one, we're going to use integration by parts. I'll just write IBP, which stands for integration by parts. And here we have to choose a u, and we also have to choose a dv. Here I'm going to choose my u to be something that I can simplify. So here u is actually going to equal x. Now the reason I chose u to be x is because I know that it's easiest to take the derivative of x. It's actually just going to be dx. And that's going to simplify it and make it easier to do this integral over here. And then for my dv, I want to choose the rest of it. So here, this is my u, this x right here. And then my dv has to be everything else. So here my dv in blue is going to be all of this. Okay? So here my dv is going to equal sine of 1/3 x. And then you also do write the dx in there. Okay. Now you can try choosing other things for u and dv, but generally you want u to be something that's going to simplify when you take the derivative. And x is something that simplifies to dx when you take the derivative. Okay? So just a little important note here. Note, choose u as something that simplifies when you take the derivative. Choose u as something that becomes simpler in its derivative. That's really the trick to the art of integration by parts. You want to let u be something that becomes simpler when you take the derivative. So here, because u equals x, that means du is going to equal dx. And as you can see, dx is a lot simpler than just x, right? Because x is what's making this integral so hard. So when we chose it to be u, now it's just going to be dx, which is going to be a lot simpler. Now the weird thing is for the dv, because in our formula we actually need a v, not a dv on the right side, we are going to have to take the integral of dv in order to find v. And when I say integral, I mean the indefinite integral, okay, or the antiderivative, but we don't need to write plus c here, because we're not done with the problem yet. Okay, so we take the integral of both sides of this equation, the blue one, so we get the integral of dv equals the integral of sine of 1/3 of x dx. Okay, so that's going to give us v equals, with the 1/3, you're going to end up dividing by it. So we're going to get sine of 1/3 of x, but we need to take the antiderivative. So what is the antiderivative of sine? Well, we know that the derivative of cosine is negative sine, so the antiderivative of sine has to be negative cosine. So when all is said and done, you're going to have negative cosine of 1/3 x, and then you're going to end up dividing by the 1/3. Okay? And you can work out that integral by hand if you want to use a u substitution, if you can't do the u substitution in your head. But this is going to give us, if we flip over the 1/3 on the bottom and bring it out front, we're going to end up with v equals negative 3 times cosine of 1/3 x. Negative 3 times cosine of 1/3 x. Okay, so there's our v. And all I did to get v was I took the integral of dv. And the integral of dv becomes v. Alright? But I'm going to go ahead and erase these integral symbols because we are going to need to plug in dv into the formula. So what we do is now we have it in the form integral of u dv. So it's in the form integral of u dv. And we know what u, du, dv, and v are all. So we can use this formula now. Okay, so writing it down here, we have the integral of u dv. Let me use the same colors just to make it easier. So the integral of u dv is equal to, we said the formula was u times v minus the integral of v du. Right, that's the integration by parts formula that I wrote up here. uv minus the integral of v du. So on the right side, if we did our integration by parts correctly, this should be something that should be easier to take the integral of. Okay, so let's go ahead and plug in the red and the blue functions in here. So the integral of u dv on this problem is going to be uv. So here we said u was x. Okay. And then v, we calculated, was negative 3 cosine of 1/3 x. And we don't write a plus c because we're not actually at the end of the problem. Okay, at the very end of the problem, because this is an indefinite integral, when we're done with everything, I'm going to write a plus c. But there's no point in having to write it in every step. It's just a lot of extra work. Okay, so we've got our v is negative 3 cosine of 1/3 x. Negative 3 cosine of 1/3 x. Okay, so this one is u, and then this one is v. And then we have minus the integral of v du. Minus the integral of v du. So for minus the integral of v du, once again we said that v is negative 3 cosine of 1/3 x. Okay, so we have the integral of negative 3 cosine of 1/3 x. Okay, and then we have that times du. But we were smart and we chose u to be x, so du is just going to be dx. Okay, and because we were smart about choosing u to be something that became simpler when we took the derivative, now all we have to do is this integral here, and that one's a heck of a lot easier than the original one. Okay? So over here we don't even have to do an integral, so we just have negative 3x cosine of 1/3 x. And then for our integral over here, the minuses cancel, and we can bring the 3 out front. Okay, so we have plus 3 times the integral of cosine of 1/3 x dx. And over here we still have the negative 3x cosine of 1/3 x. Oh my goodness. I'm tired. Okay. Sorry my writing's getting a little bit sloppy because I'm just tired. Also, it's just a lot to write. Okay, so what we got here is all this business, and then so here this integral is a lot easier to do. So taking the antiderivative of cosine, that's going to give us positive sine. Okay, so we're going to get positive sine of 1/3 x. Okay, and how do I know that it's positive sine? Well, I can either use my formula sheet, or I can just think about it. The derivative of sine is positive cosine, so the antiderivative of positive cosine is sine. Okay, antiderivative is the same as the indefinite integral. And then when you're doing u substitution like this, you end up dividing by whatever factor was on the inside of your function. So we're going to end up dividing by 1/3 here. So I'm going to be doing divided by 1/3. And we still have a 3 out front. Okay, and over here we still have a negative 3x cosine of 1/3 x. Okay, and now I'm getting close to the end of the problem, so I need to remember that this is an indefinite integral, and we're almost done here, so I'm going to go ahead and start writing my plus c so I don't forget. Okay, and then if I flip over this 1/3 here that we're dividing by, it's going to be flipped over and we're going to have 3 on the top, and 3 times 3 is 9. Okay, so that second term is now going to be 9 times sine of 1/3 x. Okay. Okay, so now we have negative 3x cosine of 1/3 x plus 9 sine of 1/3 x plus c. Again, I don't know why my writing's getting so messy. Usually it's much better than this, but I think it's because the baby kept me up a lot last night, so I'm tired. So it's hard for me to write cleanly. Okay, so what we got here is our answer. Now, as you can see, that all of that would also work if it were a definite integral and we had to plug in numbers. So at the very end here, this is when you would plug in the numbers. But because it didn't have any numbers to plug in, it didn't have any limits of integration in the original problem, this one is an indefinite integral. So at the end, I have to write plus c. So as you can see, integration by parts allowed us to do a problem where u substitution did not work. And a lot of the other advanced integration techniques that I taught you also would not work on this problem. Like, you can't really use a trig identity for x times sine of 1/3 x. There really aren't any that I know of. So integration by parts is pretty much the best way to do this problem. Whenever you have something where the integral is too complicated, but you have things multiplied together so that you can write them in the form u dv, then generally integration by parts is the way to go. As you can see, though, it does take time. That was actually the easiest problem, or the easiest type of problem that's on your homework. So it's quite a bit of work to do integration by parts. So I won't be able to do as many examples as I hoped, but I will try to do some of the harder examples from your homework, just to make sure that you understand them. Okay, hold on, let me get my notes ready here. Alright, so let's take a look at problem number 2. Okay, problem number 2. For this one, we're going to have a definite integral. So this one is actually the integral of the integral from 1 to e to the 5, the integral from 1 to e to the 5 of x to the 5th ln of x dx. Okay. So now this one is a bit obnoxious at the beginning, because Because when you see the x to the fifth, you would think that you might actually have to do this a lot of times. You would think you might have to apply the integration by parts formula more than once. But actually on this one, we don't have to do that, and you're going to see why. Now the tricky part is just choosing what our u and our dv are. Okay, so what do we want to let u be, and what do we want to let dv be? Well, again, you want to let u be something that's going to simplify, and let dv be something that you can take the integral of. Okay, so here, I would say we want to let u equal ln of x, and then dv equal x to the fifth dx. Because then u is easy to take the derivative of. The derivative of ln of x is 1 over x. And dv is something easy to take the integral of. So the integral of dv is going to be x to the 6 divided by 6. So then when we have minus the integral of v du, we're just going to have a power function, and that's not going to be so bad. So this one looks intimidating, but I don't think it's actually going to be that bad. So, but once again, we're going to do integration by parts. And with this one, I can't think of any better way of doing it than by parts, because if you use u substitution, it won't work. So we're going to do integration by parts, and we're going to let u equal ln of x. Now again, I chose u to be ln of x because when you take the derivative of ln of x, you get 1 over x, and that's something that's going to just cancel out with the power in the numerator. Because x to the 6th divided by x is x to the 5th. And then we're going to let dv be everything else. So here, this is our u in red, and then dv is going to have to be everything else. So here dv is going to be x to the 5th dx. Okay, so dv equals x to the 5th dx. All right? And then in order to use the formula, you've got the integral of u dv equals uv minus the integral of v du. So in order to use the formula, you have to calculate both du and also v. So you get du by taking the derivative of this one. So we're going to get du equals 1 over x dx. And with these, you don't want to isolate your dx. You want to just leave it as 1 over x dx. Okay? Because that's just how integration by parts works. You want your du to be in the form something times dx. So this is how you want to leave it. And then for the dv, rather than taking the derivative, we actually have to take the integral. So if I integrate both sides of this equation, I'm going to get v on the left side, and then on the right side, using the power rule, I'm going to get x to the 6th divided by 6. Because remember, the power rule for integrals is you add 1 to the exponent, and then you divide by the new exponent. And once again, you don't want to write plus c here, because this is just like a mini integral that we have to do to find v. And this one's actually not even going to be an indefinite integral, so you would not want to write a plus c. Okay, but we just integrated both sides of the blue equation up here to get our v. Okay, so we took the derivative to get du, and we took the integral of dv to get v. And now we're ready to plug everything into the formula. Okay, so we're going to have uv minus the integral of v du. So let's plug everything in. So we said u is ln of x, and v is x to the 6th divided by 6. Okay, so we have ln of x times x to the 6th divided by 6. I've been told my 6's look like b's, but I'm not sure what to do about that. I'm trying to make them look less like b's, but I don't know. It's just my writing. Okay, so you got uv, ln of x, times x to the 6 divided by 6. And then we have minus the integral of v du. So it's going to be minus the integral of x to the 6 over 6 times 1 over x dx. Okay, so minus the integral of v du, so that's going to be minus the integral of x to the 6 over 6 times du, which we said was 1 over x dx. Okay, and as you can see here, I was smart about what I chose for my u, because I knew that if I took the derivative of ln of x, I would get 1 over x. And now we can just subtract the exponents here. Because remember, if you're dividing exponentials with the same base, you subtract the exponents, and you do that top to bottom, left to right. Okay, so this one down here is actually just x to the 1, and then we subtract the exponents. So we're going to get the integral of x to the 6 minus 1, and we can factor the 1/6 out front. Okay, so we have a negative 1/6 out front. Okay, and then back here we have, I think the standard way of writing it would be x to the 6 over 6 times ln of x. Or maybe they would write it as 1/6, let's see, they would probably write it as 1/6 x to the 6th times ln of x. Over here. Okay. And then, of course, 6 minus 1 is just 5. So here, we're just really going to be integrating x to the 5th dx. And the integral of x to the 5th is, once again, x to the 6th divided by 6. So here we have x to the 6th divided by 6. And then we still have a negative 1/6 out front. And we do not want to write a plus c for this one, because this one was a definite integral. So what we're going to end up doing here is we're actually going to be plugging in the limits of integration. So we're going from x equals 1 to x equals e to the 5. I know that it's in terms of x because the original independent variable and the original integral was actually x. So x equals 1 to x equals e to the 5. And we're going to be doing that for this entire expression. Okay, for both terms. We're going from x equals 1 to x equals e to the 5. Okay, and for that second term there, instead of writing it as negative 1/6 times x to the 6 over 6, we can actually multiply the 6 times 6 on the bottom, and we're going to get 1 over 36. So I'm going to go ahead and rewrite this one as negative 1 over 36 times x to the 6th. Okay, so now that everything's all simplified and we've finished the integrals, now we're ready to plug in these limits of integration. So remember, with a definite integral, you always plug in the top number first, and then you subtract the function evaluated at the bottom number. Okay, so plugging in e to the 5th, we're going to have 1/6 times e to the 5th to the 6th times ln of e to the 5th minus 1/3, sorry, not 1/3, 1/36 e to the 5th to the 6th. Okay, so there I just plugged in the top number, e to the 5th, everywhere I had an x. Okay, now I subtract the function evaluated at the bottom number, which is 1. So I'm going to have minus 1/6 times 1 to the 6th times ln of 1 minus 1 over 36 1 to the 6th. Okay, I know that's a lot, but and notice that I put brackets around this second part. That's because I know there's a minus here, so we're going to have to distribute the minus to each of those terms. So that was just plugging in the top number and the bottom number and subtracting. Okay, and then we can simplify this. So first of all, for this first term over here, remember that if you have ln and e combined with one another, they're inverse functions if they're composed with one another, so they just cancel out. So this ln and that e cancel out, and we get 5. So for this first term, we're actually going to have 5 on the top and 6 on the bottom. And then for the e to the 5 to the 6, if you're raising a power to another power, you multiply the exponents. So this is going to be e to the 5 times 6, which is e to the 30. So we have 5/6 e to the 30. Okay, and again, that 5 came from here because the ln and the e canceled, so that 5 came out of the exponent and became a constant. Okay, and then over here, once again, e to the 5 to the 6, you multiply the exponents, so you get e to the 30. So we have minus 1 over 36 e to the 30. And then further on over here, we have minus bracket. Well, this first term, remember that ln of 1 is 0, because this is really log base e, which means e to what power gives me 1? Well, e to the 0 gives me 1, so ln of 1 is actually just 0. So that's right, that right there is just 0, so this first term is actually 0. So all we have to worry about is the second term, but 1 to the 6 is still 1, so we really just have a negative 1 over 36 here. And then we still have a minus out front because we were subtracting. Okay, and then what we can do next is we can just simplify this a little bit. So for this one and this one, these are like terms because they're both e to the 30th power, but this one doesn't have the same denominator as that one. So we're going to need to multiply this fraction by what we're missing. So what we're missing is, here we have a 6, here we have a 36. So in order to have the same denominator, we're going to have to multiply this first fraction by 6 on the top and the bottom. So we multiply this one by 6 on the top and the bottom. So on the top we get 6 times 5 is 30 over 36 e to the 30th. And then we have minus 1 over 36 e to the 30th. And then over here, this minus and that minus cancel out. So we're just going to be adding 1 over 36. Okay, and now we can combine these first two terms because they're like terms now and they actually have the same denominator. So 30 minus 1 is 29. Okay, so we get 29 over 36 e to the 30th plus 1 over 36. And that's actually going to be our final answer. And I think that's something like the form that they wrote their answer in. Let me check. Yeah, that's what they got. So, and by they, I mean my math lab, not the voices in my head. Okay, so what we got here is 29 over 36 e to the 30 plus 1 over 36. And remember, when you're plugging in numbers, you do not write plus c at the end, because it's a definite integral. Okay. So hopefully that one wasn't too bad. Okay, so for my third example for this video, I wanted to show you a problem that's similar to one of your homework problems. But for this one, we actually end up having to do integration by parts, but we have to do it more than once. Which is, integration by parts, as you can see, is already a lot of work. And now it's going to be even more work. But it is useful, it's just time consuming. It's not so much hard as time consuming. Okay, so example number 3. When we first look at this problem, we think we're just going to be able to do integration by parts once, but it's going to turn out that we're going to have to do it again. So this one is the integral of x squared times cosine of parentheses 3x dx. Okay, the integral of x squared cosine of parentheses 3x dx. Okay, so as usual, this problem is not doable as far as I know with any other method, because u substitution definitely would not work here, and then really there's not really any other ways of doing it unless you use a computer to do the integral algebraically or numerically. Okay, so anyway, we're going to be doing integration by parts, and once again we want to choose u to be something that simplifies when we take the derivative of it. So we don't want to let u be cosine of 3x because the derivative of cosine is negative sine. That's not any simpler. However, if we let u equals x squared, the derivative of x squared is 2x, which is simpler. So that's what we want to let our u be. U needs to be something that simplifies every time you take the derivative. Even if you have to do integration by parts twice, you still want to choose something that simplifies in each time. That way, once you do it twice, you've gotten rid of this factor here, and then it's easy to do the integral. Okay, so integration by parts, IBP. Once again, letting u equal something that will simplify. So here u is going to equal x squared. Okay, and then we're going to let dv be the rest. So since u is x squared, dv is going to be the rest of this, so it's going to be cosine of 3x dx. Okay, dv equals cosine of 3x dx. So of course, to use the formula, it's still going to be the same formula, so it's going to be uv minus the integral of v du, uv minus the integral of v du. So just like before, we need to calculate du by taking the derivative of the first equation. So taking the derivative of this equation, we get du equals, using the power rule, we bring the exponent out front and we decrease the exponent by 1. So we get 2x dx. Okay? And then for the dv, we have to take the integral to get our v, because remember we need v on the right side here. So we have to take the integral of this. So we're going to get v, taking the integral here, we're going to get v equals, well, the antiderivative of cosine is going to be positive sine because the derivative of sine is positive cosine. Alternately, you can just use the formula sheet. The integral of cosine of u du is going to be sine of u du. And if you do a u substitution here, like I said, you end up dividing by whatever the coefficient of the inside function is. So here we're going to end up dividing by 3. If you don't believe me about that, you can always work through that part of these problems with our u substitution. You would let u equals 3x, take the derivative, then you would get du dx equals 3. But after you do that, you end up dividing by 3. So here we're going to get sine of 3x divided by 3. Okay, and then the standard way to write that, though, would be 1/3 sine of 3x. So let me write it in the more standard way. So 1/3 sine of 3x. There's our v. Okay, so now we have our u, our du, our dv, and our v. So we're ready to plug everything in to the right side of the formula. Okay, so the formula is uv. Okay, so uv. Well, let's see. In this problem, we said u was x squared. And then we just said v is 1/3 sine of 3x. So we have times 1/3 sine of 3x. Okay. And then we're going to have minus integral of v du. So we're going to have minus the integral of v du. And so what's that going to look like? it's going to be minus the integral of 1/3 sine of 3x minus the integral of 1/3 sine of 3x du. Now on this problem, du is a little bit more complicated than the other ones. Here du is actually 2x dx. Okay, so 2x dx. Okay, so you got uv minus the integral of v du. So I know I already let the cat out of the bag. I let you know what the problem with this one is. So if we look at this integral here, sadly, we can't do it with u substitution, this one right here. Because if you let u be 2x, or let u be sine of 3x, it doesn't matter. Nothing's going to cancel out. So u sub doesn't work here. Okay, so u substitution fails here. So what does that mean? That means you have to do integration by parts again. So we're going to do IBP, integration by parts, again. All right, and once again, you need to choose your u to be something that simplifies when you take the derivative. So if I go ahead and factor out the 2 and the 1/3 here from this integral, I'm going to have a negative 2/3 out front. So let me do that first. Okay, so out front here, I'm going to have a negative 2/3. Okay, and let's see, we didn't have a minus there already, did we? No, we only have one minus there. Okay, so that's going to be minus 2/3 integral of sine of 3x times x dx. Okay, and then, so when we're doing our integration by parts again, we're just going to be doing integration by parts on this integral here. But don't forget, we still have all of this out front. But we're going to just be focusing on this one right here. So let me circle it in red. This is the one that we're going to be focusing on, and then we'll end up plugging that in at the end. So for the one I circled in red, we're going to let u equal the thing that will simplify when you take the derivative. So we're going to let u equal x, because the derivative of x is dx, so that simplifies. And then we're going to let dv be the rest of it. So dv here is going to be equal to sine of 3x dx. And you do actually have to include your dx and your dv. That is important. Okay, so and then as usual, we're going to have to go ahead and do the derivative of u, which should be easy if you chose your u correctly. So we're going to get du equals dx, which is good. We're simplifying. And then we do the integral of dv to get v. So the integral of sine of 3x dx is going to actually be negative cosine of 3x divided by 3. Now, how do I know that it's negative cosine? How do I do that in my head? Well, I remember that the derivative of cosine is negative sine. So the antiderivative, which is the reverse operation, the antiderivative of sine has to be negative cosine. Or you can just use the formula sheet. But either way, you should have negative cosine of 3x. And then, of course, because of the u substitution, at the end you end up dividing by the coefficient of what's on the inside. So you're going to end up dividing by 3. Okay, so you get negative cosine of 3x over 3 for our v. Okay, so now we're just focusing on this integral right here. At the end, we'll plug everything back in to this huge formula. So it is going to be a long problem. Okay, so let's focus on just the part that I circled there. Actually, let me circle it in green so it looks less confusing. Circling it in red and also letting that be our u kind of makes it confusing looking. Okay, so I'll do the integral that we're going to do. I'm going to write that in green. So that one's in the form the integral of u dv, okay, and that's going to be uv minus the integral of v du. Okay, and we're just focusing on the part that I circled in green right now, and after we calculate that, then we can plug it back in to all of this here. So we can plug it in for the part that I circled in green. Okay, so integral of u dv is going to be uv. Well, we said u was x and v was negative cosine of 3x over 3. Well, we can simplify that to write it the way they usually do, which is going to be negative 1/3 cosine of 3x. Okay. So our uv is going to be x times negative 1/3 cosine of 3x. X times negative 1/3 cosine of 3x. Okay, so there's our uv. Okay, and then we have minus the integral of v du. So here, sadly, we have to do another integral. So we have minus the integral of v, which is negative 1/3 cosine of 3x. Okay, so negative 1/3 cosine of 3x times du. Well, fortunately here, we finally simplified our u down to a dx. So here du is just dx. So this is very time consuming, I know. However, it's a little bit easy in some ways. It's just tedious. The difficult part is just to make sure you don't miss anything, like forget a minus somewhere. And that does happen, by the way. So you might want to check your work when you're doing these because the problems are so long. All right, but here we can rewrite this first term as negative 1/3 x times cosine of 3x. And then for the second term, if we factor out the negative 1/3, bring that out front, the minuses are going to cancel out. And so we're going to have a plus 1/3 times the integral of cosine of 3x dx. Now, I know that the derivative of sine is positive cosine, so I know the antiderivative of positive cosine has to be positive sine. Okay, so this integral here, the antiderivative, is going to be sine of 3x. But then remember, you end up dividing by the coefficient. So we're going to end up dividing by 3. So we have 1/3 times sine of 3x over 3 for this integral here. And then we still have also all of this. So we still have negative 1/3 x cosine of 3x over here. Okay, and then because I'm too lazy to rewrite all this again, I'm going to go ahead and multiply these 3's on the bottom for the second term. So 3 times 3 is 9. So actually out front here, for the second term, we're going to have 1/9 times sine of 3x. 1/9 times sine of 3x. Okay? Alright, but all we did right there was the green integral. And that was the last thing we had to do before we can plug it in. So now we're going to plug in this whole thing. I'm going to circle it in green. And we're going to plug it into that integral up there. Plug all this in up here. But don't forget, we still have the rest of this. So I'm going to have to zoom out a bit so that we can see everything. So don't forget, we still had all of this. So our final answer is going to be written down here. Oh, I'm not good at writing that small. Let me zoom back in. I was going to try to write really small, but it's difficult on this tiny little drawing pad that I use. Okay, so final answer is, well, plugging in here, this one we can bring the 1/3 out front. So we have 1/3 times x squared sine of 3x. Okay, 1/3 times x squared sine of 3x. All right, and then we also had minus 2/3 times the green integral. So it's minus 2/3 times the green integral. So I'll put brackets around the green integral. And then plugging in everything in green, we had negative 1/3 x cosine of 3x. Negative 1/3 x cosine of 3x. I guess technically we're going to have to simplify this before we have our official answer. Okay, and then we also have a plus 1/9 sine of 3x. Okay, plus 1/9 sine of 3x. So because what I was plugging in there had more than one term, I had to put parentheses or brackets around it. But that thing that I circled in green, that's this integral up here. And that was what we did over here. That was the last thing we did. And so now we're just plugging it all in. And it's quite a mess. Well, not really a mess, but it's just long. So I guess it's not technically the answer yet, so I shouldn't be writing that. But we're getting close to the answer. So here we're going to distribute this negative 2/3. So we're going to take this negative 2/3 and distribute it to each of those terms. Okay? And remember that you multiply fractions straight across, so you multiply the numerators and the denominators separately. Okay, so for this middle term, the minuses are going to cancel, and so we're going to get 2 times 1 is 2 on the top, and then on the bottom, 3 times 3 is 9. So we're going to have positive 2/9 times x cosine of 3x. That's for our middle term. Okay, and then for our last term over here on the right, distributing the negative 2/3, we have a negative times a positive, which is a negative, and then multiplying the numerator and the denominator. On the top we have negative 2 times 1 is negative 2, and then on the bottom we have 3 times 9 is 27. So you should have negative 2 over 27 sine of 3x. Okay? And then back here we still have this. So we still have 1/3 x squared sine of 3x. Alright, and then we would think that we were done, right? But I did forget one last thing. Was this an indefinite or a definite integral? Oh, I don't remember. Let me go check. Oh, well, because we're not plugging in numbers on the top and the bottom of the integral, it's an indefinite integral, which means the last thing I need to do here is zoom out a little bit more and write plus c. Okay? And that's our final answer. Okay. So I'll box that. And let me check. Yes, we did all of that correctly. So we got the same answer as my math lab, which is pretty cool. Okay. All right, that completes this lecture. Thanks for watching.